All right, so yeah, I was introduced earlier as part of the board of GNU Radio, but I actually also work for a company called NI, and we've been sponsoring this conference for a long time, which I'm very, very happy about. So they pay me to fly here, and of course talk about our products, which I'm also proud of. And this is the USRP X440, our latest, and I don't want to say, yeah, I can say the latest and greatest in the USRP product line. Not that the others aren't so great, but I'll be talking about this for a few minutes. So yeah, just to be clear, this is not me speaking in a GNU Radio capacity. This is me speaking in an NI capacity, and this is our sponsor talk. So I will use this time to brag about our product line. Okay, the X440. Let's look at some stats. What can it do? What's so special about it? Sort of the general tagline for the USRP X440 is like just more and better. And what do we have more of, and what is it better than? And if you look at the number of channels, you can see it has 8 channels, TX, RX. You can do full duplex, or you can do half duplex over a single port, the same as you were able to do with any other USRP in the past. So we have a lot more channels. That's number one. And of course, very interestingly, so each of these channels can handle up to 500 megasamples, or like a 400 megahertz of analog instantaneous bandwidth. If you are okay with not using all 8 channels at a time, you can go up to 2,000 megasamples, or 1.6 gigahertz of instantaneous bandwidth per channel, which makes this very useful. And this sort of unlocks new capabilities that you couldn't do with an X410, for example, or even an X310. The one thing that might stand out a little bit is the frequency range is actually dropped compared to other devices. So 30 to 4 gigahertz, what's that about? And the answer is we've simplified the RF section in this device intentionally to make this a device that is primarily to be used as an IF device. So, all the other USRPs, you could effectively put an antenna directly on, and they would be useful. Like they would have like reasonable output power and, filtering and whatnot. If you wanted to go fancy, you could connect a RF conditioning device like the SE2430 to the X410, but the X410 by itself is a useful device for transmitting and receiving directly. But there are many use cases where you need some kind of specialized RF hardware, and then this comes in handy because this sort of offloads the RF conditioning problem outside of the box, which is how we were able to fit all those channels in. I'll talk about that a bit more in a sec. Quickly mention some other stats. In almost all other respects, this is the same hardware than that the USRP X410 already had. So it even uses kind of the same, like the box looks very similar. It has an RF SoC, the same one as the X410. The only difference is that we are using a speed grade 2 device here. Other than that, you have the same interfaces and the same interfaces that you can sort of use for sort of the digital connections. If we look at the front, you can see, well, a bunch of connectors. Unsurprisingly, we have 8 channels to handle. So that means a lot of connectors. We couldn't actually fit 8 SMAs per daughter board. So these are MMPX connectors. So if you might need some adapter cables for your existing RF. But other than that, you just have a whole bunch of RF coming in and out of this device. And if we flip it around and look at the back side, it looks exactly like an X410. So I don't need to talk about this in all great depth. Just to reiterate that we do have the same 2 times 100 gigabit Ethernet connections. You can also do 10 gigabit, of course. Synchronization, PPS, 10 megahertz, etc. And the same digital interfaces, USB. And of course, you have 1 gigabit Ethernet, which can come in very handy for management. You can also stream over that 1 gigabit Ethernet interface, but not very quickly. Remember, this is a 2 gigahertz, a 2 gigasample device per channel, so you're not going to do that over that 1 gigabit Ethernet connection. If we put it side by side with the X410, you'll see all the things I just mentioned. We have more channels, we have more bandwidth. We have a different frequency range because this is supposed to be used for sort of IF applications. And if you look at the other interfaces, it's pretty much the same. It supports UHD, RFNoC, and through that, it of course supports GNU Radio. We're hoping to see some more software support by other software vendors in the future. But we think that this device will actually be used in different applications than the USRP X410. So we didn't just want to upgrade the X410, we actually wanted to build a different device for different reasons, and that's what we did. So one thing, sort of just to sort of wrap up the stats section of this device, if you look at the block diagram of this device, on the motherboard side, unsurprisingly, it looks like the X410 because it is using the same motherboard as I mentioned before. On the daughterboard side, it's much simpler though than the USRP X410 because we are now removing that that RF circuitry to fit all those channels, which means basically all we have are some balance there to actually connect the front panel connectors to the high-speed converters. There we go. And the main and sort of key feature that we're providing with this device is access to hundreds of sampling rates. So this comes in, very handy. Now the RFSoC is a good IC that we've been using, but it is complicated to program. So there's a lot of stuff that you need to know. And here's a screenshot from our manual that sort of grew in complexity as we were adding to it. You can see up to 5 PLLs on here, and that's hiding the fact that some of these are dual PLLs and others are 1 PLL per channel. So there's lots and lots of stuff that you have to program on this device if you want to actually sample at like variable sampling rates. And we sort of try and take all of that away and sort of fold that neatly into UHD. So you can just request a sampling rate like you could with any other device in the past. And you would get that. So we go all the way down to 125 megasamples on the low end. Of course, you can do further processing and get it further down if that's what you need. But what we can actually natively produce from the converter goes down to 125 megasamples and up to 2048 megasamples. And then there's like all sorts of rates in between. Multiples of 100 megahertz. We have the various 5G rates available. And for the most part, you can just ask for a rate and UHD will figure out what to do and give you that rate. Now, what do you actually do with an X440? Of course, we'll see next year what people have been doing with X440s because it's not like this is still very new. We were actually glad to have something to show for this GRCon, so it's not a lot of people have been using it so far. But we have a couple of ideas, and the fact that you have 8 channels that can phase coherently produce and consume data makes it an option for doing direction finding. Now, if you have to move out of the 30 to 4 gigahertz frequency range, then you would connect your external up and down converter. You definitely want to have some filtering, but there you go. You have 8 channels in one device, like 1/2 RU space that you can use. And of course, you can combine 2 of them, then you would have 16 channels and so on for building, setting up a uniform linear array or something like that for direction finding purposes. So that's an obvious application. If you're running a satellite ground station, then we can't tell you anything about RF conditioning and filtering. You probably know more about that than we do, and you probably already have it set up in your satellite ground station. So the fact that the device itself doesn't have all this, like 5G compliant filtering is not really a downside for you. And then, this is a natural fit because again, you have a lot of channels in a small rack space. If you're working on radar, you want the high bandwidth, and that's where we've actually unlocked something new, going from like previously 500 megasamples per channel to 2000 or 2 gigasamples per channel. So that does unlock new applications. Of course, you need some powerful signal processing on the side, and you probably, or in almost all cases, want to have some external RF up and down conversion, filtering, etc., like I mentioned before. But this is definitely something that that unlocks new applications. Now, you could also do some. There's supposed to be an animation in there. I don't know if this is the PDF or the PowerPoint. Okay, I'm just going to have to assume that the animations aren't working. They are hiding like some of the boxes though. What it says on the left-hand side under the green pentagon is wireless comm software stack. So this is the idea that you might be running some kind of 5G, 6G software stack. And on the right-hand side, you could be using an FR2 up and down converter for millimeter wave. Now, why would you do that with an X440 and not with an X410? Where the X410 is the device that we typically advertise as useful for, these kinds of applications like wireless comms research, is because these external up and down converters make it a perfect match for this IF-based receiver. So there's a company called TMY Tech, which sells up and down converters. They also have like beamforming antennas that you can connect. And we actually have some at our booth, so you can come and take a look at them. But there's also other companies that sell these devices that you can match nicely with an X440. And now pretend that these green pentagons are magically moving onto the slide. What I wanted to point out here is that in all the example applications that I mentioned earlier, you always have two problems that you need to solve. Well, you have plenty of problems, but there are two problems in particular that are common to all these applications, which is you want to stream data up and down from the device at a high rate, and you might want to facilitate accessing the external RF front end into your software. And we have solutions to both of those problems. So first of all, one thing that we've introduced a while back is the extension framework that we originally introduced for this device at the bottom, sort of right, the SC2430 signal conditioning device, which is built by a separate company than NI that we've partnered with called SignalCraft. And this extension framework allows you to connect an RF extension box to the device. It could be, well, it could have its own, Ethernet connection, but in this case, it actually uses the digital controls on the front end of an X410. And the idea is that you tell UHD what you're trying to do, as in, I'm trying to run an USRP in combination with this RF extension box. And then UHD will abstract away the RF extension and try and make both devices appear as a single device. So I don't know if you can actually read this from behind, but like in this GNU Radio dialog here, we add a device argument that says extension equals SC2430, and that'll prompt UHD to go find a binary plugin that'll then load. And if the RF front end changes the available frequency range or gain range or whatever, then the device will report like whatever that frequency or gain range is. And you can, so if you had a front end that went to millimeter wave and you say, okay, I need, I don't know, like 28 gigahertz or whatever center frequency, then it'll simply choose that center frequency for you, assuming that you have an appropriate plugin for this. And the other thing is the whole streaming problem. Now in the past, whenever you was streaming data from a USRP, like all the streaming data went through the same UHD session that also set up your frequency, your gains, and I don't know, antenna ports, whatever else you need to configure. And we've sort of changed UHD in the past, so you don't have to do that if you don't want to. If you think that you can handle the streaming better elsewhere and within your own software, and that's not unlikely because you know better what your application is, then you can have a UHD session, set up the USRPs, again, set the frequencies and everything else that you need, the sampling rate, whatever else, and then tell the device to stream its data to a remote processing node. And because this is all like built into RFNoC and RFNoC compatible, you can also build blocks into the FPGA that do some kind of pre-formatting of the sample data. And last year we had a guest slide from Microsoft where they actually showed how they built an RFNoC block to generate Diffie-compliant VIDA49 packets that then came off the device and could be consumed by a VIDA49 compatible receiver. All right, I just mentioned RFNoC. Who's familiar with who's heard of RFNoC here in this room? Oh, that's a lot of hands. Wow, I think that might even be more than SIGMF. I'm going to give myself a pat on the back for that. RFNoC is our framework that lets you integrate custom IP into the FPGA of a USRP without having to modify UHD or anything else. Of course, you need to build a custom bit file, but the way that you integrate the custom IP is standardized. So UHD will query the device for its capabilities, and it might say, oh, I have this custom RFNoC block in there that's running some kind of custom IP, or it's an FFT or an FIR filter or whatever. And in the past, you could use RFNoC with GNU Radio in a graphical fashion, but you would have to install an external separate out-of-tree module called GREdus. And we've been slowly upstreaming all of that into GNU Radio now that we think that the API is appropriately stabilized. And The current GR-UHD support for RFNoC actually supports more blocks and options than the original GR-Ettus did. So I, highly recommend people to move over. Of course, you need the latest GNU Radio release to get all the features. But that's where we're sort of putting our attention these days. And one thing I want to point out is like Jeff, our MC, who just introduced me, was actually very helpful, giving us appropriate feedback on the whole upstreaming thing, because now we are moving our code into the common GNU Radio code base. And if RFNoC and our blocks and our demos, there's one thing that stands out a little, which is phosphor, so you might have seen the GPU accelerated phosphor, which is really cool looking waterfall histogram display. And we have an RFNoC version of that where the pre-processing is done in an FPGA, and it simply sends all the data over to the the host computer that is required to do the visualization. And that included a Qt based sync, which we have also put into GRQDegree, and that was something that Jeff gave us more feedback on. And I'm going to give a little bit of a sort of a business secret away here. You should, if you're a company in the SDR space, it helps to work closely with the GNU Radio maintainers. It'll make your life a lot easier. So I can highly recommend that. And thanks again to Jeff for helping us upstreaming that. So in the current version of GRQDegree, you actually have sort of a standalone demo that shows how you can just put raw samples into that sync and then display them the way we do on the left. Still doesn't look as cool as the original GR Phosphor, but it is definitely nice to have. A couple of other things that we've been working on, and this is just sort of I'm going to rattle off a short list of things that we've been working on in the last year. We've been working on FPGA usage for those people who are actually modifying FPGAs, for example, to integrate their own RFNoC blocks. This was necessitated, there was public demand for that, but also for the USRP X440, we really had to do this. In the past, if you built a custom design, you had the option to choose a bit width, which sort of gave you a maximum available bandwidth. The maximum bit width that we support on our devices is 512 bits per bus. And if you want to do 100 gigabit Ethernet streaming, that's what you need, because otherwise you can't shift enough data over the available buses. Now, that's a lot of bits to route. And if you had a design like this with a crossbar, that automatically generated a whole bunch of routes that needed to be somehow placed and routed and put on the FPGA. It was very difficult to accommodate. So we've changed that so that you could, first of all, you can mix and match bus widths to a degree. So you can have a 512-bit bus on your 100 gigabit Ethernet connection, but then use a lower bus rate elsewhere where you won't need the high bandwidths. And you can also leave out routes on the crossbar because that might be what your application actually needs, and that way you can save a whole bunch of resources and make building FPGA images easier. And we have a bunch of other things on the FPGA side. This is not, most of this is really sort of in the details, so I'm not going to go through it in all that much detail. Maybe if you have questions, you can approach me about that. One fun little thing that we notice is if we produce data at line rate on a 10 gigabit Ethernet link, so we send data from a USRP into a computer at line rate without any interruptions, back-to-back packets. NICs won't often be able, NICs as in network interface cards, won't always be able to keep up. So even if you have a reasonably powerful computer, the network interface might say, oh, I've been dropping packets left and right because I can't quite keep up with the data rate that's coming out. And this is nothing that we can catch with our flow control. So we put a little feature in that you can actually slow down USRPs. It seems a bit silly, but for some applications, this is just really useful if you want to download a bunch of data from the DRAM. It's one of those little things that you run into and you're like, I guess I have to fix this now. And yeah, we did. And UHD 4.5 is not quite ready, is not released yet, but the release candidate is out, which means I have high faith that the team that is going to finalize that release will have that out in the in the near future. It has a bunch of features, but mostly the X440 support. Of course, we've been putting in a lot of bug fixes, and even just small things that I personally find are very important. Like you can compile UHD on many platforms, many compilers without any warnings, for example. I find those things to be important just as a as a metric of quality, and I'm very glad that we are able to sort of maintain that. All right, that wraps it up. Again, I'm very, very happy to be here, not just as a GRCon person, but also as representing NI, because this is this is an important conference for us. We are very happy to be here and very proud to be sponsoring, for so many years in a row. We have a booth in the coffee break area, which you've probably seen. You can talk to any one of us wearing like these green NI/Ettus Research shirts. There's Hayden is at the booth. Neil is doing a workshop, I think today, one on RFNoC that you can visit. Yeah, talk to us about USRPs, and we hope we can help you with your various applications. All right, that's it from us. That's it from us. Thank you very much. I think I might have time for a question or two, but I also realize that it's time for lunch soon, so I will not be upset if you want to get some food. Well, again, thank you very much, and I hope to talk to you about USRPs.